Hello and welcome back. Last time, we spent some time talking about one of the constraints for writing virus code. It must be self-contained and not linked to any external libraries due to the inability to locate external symbols at runtime. We also talked about not using RO data in data sections because they typically require different access permissions. It's very hard to find locations that are both executable and writable to inject a virus. The workaround is, of course, using a special version of the C library provided by the virus framework that has most common functions you need. In this video, I want to talk about one of the tricks to force compilers to not generate things in RO data section when you write a virus. For those who don't know, RO data section is where the compiler puts things like constants or string literals. We saw this test virus last time that just prints hello world using the special version of the libc from the virus framework. Because the write syscall requires that the string to be printed must be initialized and null terminated, the code uses a magic macro called string literal wrapping around the string we want to print. What does this macro do? Let's first remove it and see the generated code. I'm going to use this Bazel build command to compile the virus. And then use obj dump tool to see what sections are generated. The test virus has a text section, an RO data section that has our string literal. Let's disassemble the text section. The string literal is at file offset 1090. And it's referenced here by the code in the text section. The ADR instruction basically calculates the real memory address at runtime for our string literal using a fixed offset. In other words, our text section needs to find the string literal using a fixed offset regardless what runtime memory address it has. If anyone wants to inject this block of virus code into an arbitrary program, they will also need to inject the RO data section of the virus while maintaining the same offset. And that's a bit complicated for most viruses to find both an executable place for code and readable place for RO data. Therefore, we want to prevent the use of RO data section altogether. The way to do this is via the string literal macro. And let's see what happens if we use it in the code. Let's rebuild the virus. And then check the sections. We no longer have a RO data section. And if you haven't spotted it, this time, the string literal is embedded inside the text section. Let's disassemble the text section. We have this blob of weird instructions here, as the disassembler is treating the raw string embedded inside the text section as instructions. This indeed solves the problem of having text section referring to the RO data section, so we can inject the virus code as a simple binary blob here. How did this macro move the string literal from RO data to text section? It's actually pretty simple. Let's read the source together. This macro wraps a lambda function and it executes it in place. Inside the lambda function, it uses inline assembler. If you haven't seen assembly before, don't be scared because it's actually quite simple here. The ADR instruction loads the real runtime memory address of label 1, which is here. And it has the same address as the user provided string literal. Then it performs a branch instruction to label 2, which is here. And this is the end of the inline assembler. To put it in simple language, the code we run here loads the real memory address of a string literal and then jumps to the next value instruction without executing the string literal as code. Because the string literal is intermixed with other executable instructions, we don't run them as they're not valid instructions. By the end of this lambda, we return the loaded memory address of the string to the caller. The net effect is we have successfully embedded raw strings alongside the code, living inside the text section. Going back to objdump, this makes virus self-contained without worrying about the RO data section. In other words, when the text section of this virus is injected into other programs, it carries the string literal with it. This trick, however, comes with a trade-off that I have discussed here. Embedding strings into text section requires extra load and jump instructions. If the string is very small, the overhead would be relatively big. In general, viruses should be optimized for small size, so use with caution. Alright, I hope you like this trick here. Even though I only went over the ARM version, the x86 version also works the same. Feel free to take a look at the comments in code and experiment with it. You can find a link to the code in the channel description. See you next time.